Good day, everyone. What I want to do today is to provide you with an overview of the wireless wireline convergence work at the Broadband Forum. At the end of this talk, you should understand why this work is underway, some of the deployment scenarios supported, the value to the industry, and the timeframes we're working to. So how did this come about? Just over 4 years ago, a group of operators approached the Broadband Forum to work with 3GPP and add fixed access to the 5G core. The goal was to do this work in the 3GPP Release 16 timeframe. So we had a joint workshop with 3GPP in Dubrovnik in early 2017, back in the good old days of standards travel. And at the workshop, we walked through the ask from the operators, deemed it reasonable, and established how the Broadband Forum and 3GPP would cooperate to achieve convergence. The first step was to study the issues, which we completed at the end of 2018, and then we moved on to generating normative specifications. We have published our first set of specifications, and I'm going to go into a bit more detail about what they cover and what we're working on now during the course of the presentation. Fairly early in the process, we established some project goals based on guiding principles. A key one was to have minimum impacts on the 5G core to ensure this was a true convergence play and simply not gluing fixed access onto the 5G core with a lot of hacks. The second was a broad toolkit to get from here to there. So a lot of attention was devoted to supporting legacy equipment, auto-sensing of when 5G-enabled equipment was deployed, etc. And of course, we wanted to maximize the addressable market. What that meant was, and we were warned of this, no two operators would have the same starting point, and we would need to accommodate existing wholesale models for access, and we'd have a plethora of other considerations. Now, to our benefit, we have a very vocal group of operators pushing their requirements into the work. This has resulted in a number of important decisions as to what we specified. A big one, and probably one of our biggest challenges, was support for legacy residential gateways. This worked into a number of areas of concern for operators, primarily decoupling 5G rollout from CPE upgrade and addressing bring your own device models where the operator did not necessarily have control over the equipment the subscriber deployed. This led to the specification of the dual mode access gateway function. This is the primary mediation platform between existing fixed access and the 5G core. And the goal of the AGF was to translate whatever it received into 5G, and again, to minimize the core impacts. And we specified the AGF so it could be deployed connected to existing access equipment, PON and DSLAMs, etc. This played into a number of regulatory and wholesale scenarios. It also meant tightly constrained protocol choices for 5G. This chart is a complete view and is actually indicative of the scope of the work jointly undertaken by the Broadband Forum and 3GPP. This is lifted from TR 470, our architecture overview document. Among other things, you'll find an explanation of the components and their role in making convergence a reality. The components in green are either functions or interfaces specified by the Broadband Forum, and the associated specifications are identified on each. Those in red are those that were modified for WWC by 3GPP. The functions and interfaces named in black didn't require modification, but are part of the overall architecture. Now, this may kind of look like a spider farted on it, but it's all the use cases rolled into a single diagram, both what we've specified already and what we are working on. So we've published the first set of specifications in 2020, what we refer to as phase 1, or just enough convergence to get your feet wet. Included is legacy RG support for the higher running use cases, 5G RG support over either wireline or fixed wireless access, 5G quality of service support, and we see that as a fairly big one as it permits an operator to get to a uniform QoS model across all networks with implications for service convergence, charging, etc. Efficiency in packet handling was also a big operator concern, hence the procedures are defined to allow a combined mediation platform, AGF or FMIF, and the 5G user plane function. This eliminates a fair bit of packet processing from the end-to-end path. And we also wanted to bring forward the richness of the features defined by broadband user services. So TR69, 369 support with 5G data model extensions. This is a bigger force multiplier than it looks, as it permits what the 5G system exposes to the RG to be consumed. And to document this, we issued a series of specifications for 5G CPE management, the AGF, as well as an overall architecture document to act as our Rosetta Stone. So I mentioned the 5G-enabled RG. Just what is it? It's an RG that exposes the capabilities of the 5G system to the home. It has a control plane termination. In the mobile world, there's a single authenticated control session from the CPE to the network that is used to automate lifecycle maintenance for the services offered by the network. This single control session can request a number of user plane sessions for the purposes of QoS, VPN, network slicing, etc. As mentioned, it extends the 5G QoS model into the home, and this is managed using the TR181 data model. And we are working on multi-access and fixed wireless access support in the phase 2. Multi-access is becoming increasingly interesting to operators as the work setting evolves to work at home, and they face various deployment challenges as a consequence of the ongoing pandemic. The other key piece of the phase 1 was specifying the access gateway function. This is the mediation platform between the CPE connected to an existing access network and the 5G core. It supports both legacy and 5G enabled equipment. It auto-senses via backwards compatible procedures what it is that's connecting to the network, and it adapts how it treats it accordingly. So this is a key enabler of migration scenarios, including customer self-install. For legacy devices, it proxies the CPE control channel to interwork legacy IP sessions with the 5G PDU sessions. It can be deployed in existing and unmodified access networks, and some vendors will probably bundle this functionality into existing BNGs. We are now in the midst of the phase 2 work, and again, we have a dedicated group of operators keeping us on track. The key focus of phase 2 is to expand the deployment scenarios and unlock some of the value the 5G core brings to wireline. At the same time, we'll be adding robustness to the phase 1 work as we gain experience with it. Phase 2 will see 2 new specifications, one for the fixed mobile interworking function to allow 5G access via existing BNGs, and the second is to define control and user plane separation, which again will expand the deployment options available to operators. These documents are working texts 457 and 458, respectively. We are adding multi-access scenarios to support resilience, bandwidth aggregation with strong policy controls. And the operators have indicated that more flexibility in legacy equipment support is needed, and this will again expand the addressable market and the number of paths to 5G. We've had a lot of interest in converging PSTN emulation onto the voice mobile system, and we're looking to profile that. This will allow operators to collapse their voice services onto the one voice system that isn't going away. And network exposure will permit more of the capabilities of the 5G system to be exploited by wireline applications. We've also studied a number of use cases of interest to our operator community. Many of these make the case for the 5G RG more compelling. What this drives is pulling more and more of the 5G capabilities into our specifications. Some examples would include the ability to configure traffic separation and isolation in the home, and to specify mapping to VPNs and slices. And there's quite a number of use cases that fall into this category. The operator can isolate and secure craftsperson and management access to the CPE. We can implement parental controls by separating out the traffic of the children's equipment. We're also working on a number of access enhancements. And of course, I mentioned hybrid access adds reliability and bandwidth aggregation. And we're expanding and enhancing support for legacy CPE to offer new capabilities and expand the set of transformation starting points. Separation of interests and access sharing is a key case because it creates opportunities for additional ARPU by allowing multilateral arrangements for enhanced access. So this layers on top of the all-you-can-eat model without breaking it. And some examples of leveraging this capability or combined with traffic separation would include enhanced work from home, SASE and ZTNA, community Wi-Fi, distance learning, and as I mentioned, the convergence of the PSTN emulation onto the mobile voice system, which will accelerate the retirement of all the remaining non-mobile systems. So here's the project history in one chart, showing the broadband forum work and how it lines up with the 3GPP release plans. From study to phase 1 to phase 2, and undoubtedly there will be a phase 3. As I mentioned, we've wrapped up phase 1, the documents are publicly available, and we are well into phase 2 and approaching the point where we'll have tightly scoped the content for the final push to publication. This is projected to take us to the end of the year, and then of course in parallel with this we will be revisiting our backlog for our 2022 efforts. One thing I hope you've gotten out of this is compared to past attempts at fixed mobile convergence, and I have the scars, this time around is far more ambitious, addresses a completely changed world. At this point, everything else is already converged. From the appliances we use in the home, such as tablets and smartphones, to the infrastructure we're deploying in our networks. So not only are there significant drivers for convergence, but the barriers to convergence have all but been eliminated. So to summarize, this has been primarily driven by operators. There is a pre-qualified customer base. Unlike previous attempts at convergence, this is far more comprehensive and reflects more strongly the state of the industry. The operators have been very vocal about ensuring their needs are met, and we've been delivering accordingly. And we've published the first set of specifications and are well into the second, so the journey is ongoing.